Okay guys, here we go again. This is the last video and session for chapter 1 from the AQA freestanding maths qualification further maths course. So congratulations for getting to this point, and let's keep going. So it's the product rule for counting, and we're going to go straight in with a few examples. Okay, I'm going to explain what this means and how to answer these sort of questions. Right, okay, so product rule for counting. What this really means is what you're trying to do, you're trying to find combinations. So you're trying to find the number combinations of different events. So find the number of combinations, okay? That's really what this means. The best way to demonstrate this is with a few examples. So we're going to look at EG1. Now for EG1 I've got 6 cards and they're numbered 2, 3, 4, 5, 6 and 7. So I've got 6 different cards and then they've got the numbers 2, 3, 4, 5, 6 and 7 on them. And the question is how many different ways can I order all 6 cards? Okay, so how many different ways? Now one way is already done for you. 2, 3, 4, 5, 6, 7. That is one way. Another way could be 3, 2, 4, 5, 6, 7. And you can probably imagine there's going to be quite a lot of ways. I could list them all if I wanted to, but that's going to take me a long time and I'm likely to miss one out. So there must be a more systematic way of doing this, and there is, okay? So maybe just pause the video, have a think about how you might want to do this, but there is a systematic way to do this. Okay, now what I'm going to do is I'm going to put them in place numbers. So place number 1, place number 2, place number 3, 4, 5, 6. We've got 6 different place numbers where we can put the cards, and I'm going to call this row the options. Okay. So in place number 1, before I start, I could put any one of those cards, couldn't I? I could put the 2, 3, 4, 5, 6 or 7. I could put any of those. So I've got 6 possibilities. Okay. Now in the second placeholder, well, I've already used one of the cards. It doesn't matter which one I use, but I've used one of them. I'm only going to have 5 options left. I'm only going to have 5 options left because I'm going to use one of them. Imagine I'd used the 2. I would have had 3, 4, 5, 6, 7. I would only have 5 choices. In the third column, well, I've used 2 of them now, and I can use any of it, so I'm going to have 4 possibilities there. And you can see I'm going to go down a 3 option. This is not the card number, this is the options that I'm putting in this box. 2, and I've got 1 option at the end there. So, and to get the total number of options, you just need to multiply those options together. So 6 times 5 times 4 times 3 times 2 times 1, and that makes there 720 ways of ordering 6 different cards. Okay, that's the answer, 720 ways. Now, a useful thing to note at this point, a bit of mathematical notation. If you're doing 6 times 5 times 4 times 3 times 2 times 1, that is also known as 6 factorial, which is an exclamation mark. That's factorial. So something like 5 factorial, that would be equal to 5 times 4 times 3 times 2 times 1. And for some of these problems, not all of them, we sometimes can use that just to speed up the way we write our maths. Okay, so that's just a note what that exclamation mark means. It's just timesing all these numbers, all the numbers down to 1. Okay. Right, let's look at a different example now. EG2. This time I've got 6 different numbers again, but they're different numbers. Okay. 6 different single digit numbers there. Okay. Right, question 1. How many 4-digit numbers can be made? Okay, so how many 4-digit numbers can be made? Well, we've got 6 to choose from. Okay, so the best way to approach this again is to create an options table. So place number 1, place number 2, place number 3, and place number 4. Now in the first box, you've got 6 different choices, isn't it? You can put a 3, 1, 7, 9, 5, and a 5. So you've got 6 different options there for the first number. 6 options. Now you've used one of the options in the first number, so you don't have 6 anymore. You're going to have 5 remaining there. And then depending, again, you're going to have 4 left for the third option because you've already used 2 of them. And the final option, you're going to have 3 possibilities. And if we times all of those together, we get, what do we get? 30 times 12, 30 times 12, which is 460. No, 360. 360 ways. Okay, so that's not 6 factorial because you haven't gone all the way down to 1. So it's 6 times 5 times 4 times 3. Right, okay, second question. Using the same digits, how many 3 digits? How many 3-digit even numbers can be made? Okay, so how many 3-digit even numbers? That's crucial here. So maybe pause the video, have a think about how many 3-digit even numbers could be made from those 6 available numbers at the top there. Okay, right, we work it out in the same sort of fashion. So it's a 3-digit number, so we've got 3 placeholder options there. Now it's even, that's critical. That means what you've got to consider what that means for the last digit. Now if the number's even, the last digit must be even. So that last digit must be an 8. Must be an 8, so there's only one option at the end there. It's got to be an 8 at the end. Got to be. Now, if that last digit's got to be an 8, what's the first digit choice? Well, it can't be an 8, can it? It can only be a 3, 1, 7, 9, or 5, because the 8 has got to go at the end. So you've only got 5 possibilities for the first number. Now, because you've used 5 possibilities for the first number, there must only be 4 left for the second number. And again, remember, we times all those options together. There is, in fact, only 20 ways that you can. There's only 20 possible 3-digit even numbers for that selection of digits. Okay? Right, let's look at a third example. So, again, same numbers. How many numbers can be formed less than 4,000? Okay, so how many numbers less than the number 4,000 could be formed from those digits? And I'm just going to put those digits again, the same digits here, so we can look at them. So it's 3, 1, 9, 5, 8. So they're the numbers involved, okay, from those digits. So it's how many numbers less than 4,000? Okay, so we've definitely got 1-digit number. We're going to have to be systematic here. We can definitely 1-digit numbers. So how many 1-digit numbers can go in there? Well, 6, isn't there? It could be any one of those. So we've definitely got 6 options for the 1-digit numbers. Right, 2 digits. So 2-digit numbers. So we've got an option box 1, option box 2. Now for 2-digit numbers, it could be any of the first. It could be any one of the 6 could go at the front, and then that means we've got 5 possibilities for the second number. So we've got 6 for the first digit. We've got 30 possibilities for 2 digits. What about 3 digits? Okay, 3-digit doesn't have to end. It's not an even or odd. It doesn't matter here. For the first number, again, it could be anything, couldn't it? It could be any of the numbers to begin with, which means we've got 5 and then 4. So that is 120 different ways for the 3-digit numbers. We've also got some 4-digit possibilities. So 4-digit numbers. Let's box out the options we've got. Now the first digit cannot be, it's got to be less than 4,000. There's only two possibilities here. It's either a 3 or a 1. Can't be anything more than that. So we only got two possibilities for the first option there. Now the second option, well, it could be any one, or it could be, depending if you've used 3 or 1, it's going to be 3 or 1. It's going to be the other one you haven't used. And then it's the possibilities where it could be any one of the other digits. We've actually got 5 possibilities there for the second number. Now the third number, well, you've used one, you can probably see there's only going to be 4 available left. And then there's going to be 3 available left for the final digit. So for the four possibilities there, that all adds up to 120. Okay. And then you just need to add those options up. So you've got 6, add 30, add. So your final answer, you add all of those up, 240, add 36. That's going to be 276 numbers. There's 276 different numbers available from that choice that would be less than the number 4,000. Okay. Right. Okay. Let's look at the final example. Again, just a similar sort of theme, but slightly harder. So what are we on? EG. I think we're on EG3 now. EG3. Okay. Now, for example 3. So here we go. A volleyball team consists of 6 players with 6 different positions. Okay, so 6 different players and 6 different positions. Okay, now for this particular squad, so let's say Beach United, which is a volleyball team, has a squad of 12 players. Okay, so there's 12 players in the squad. Question number 1, how many different starting lineups are possible? Okay, so you've got a squad of 12. You can only choose 6 players, but there are 6 different positions. How many different starting lineups are possible? Again, maybe pause the video, have a go at this, see what you think. Right, I'm going to set it out exactly the same way. There's 6 different options. Okay, and I'm just going to call this like position. So I don't know what they call the positions in volleyball, but let's say the position is position A, position B, C, D, E, and F. Imagine each position is a different area of the court, perhaps. And these are the options available. Okay, so for position A, you've got 12 players there, and we're saying all the players could potentially play in all the positions for this question. But there's definitely 12. Any one of those players could go in position A. Okay, now position B, well, you've used one of them in position A, so there's only 11 left, and so on. C. Position D, you only have 9 of it, and then 8, and then 7. Okay, now if you times all of those together, you get an answer of 665,280 different starting lineups. Okay, so that's quite a big number, and you can see where the challenges of picking a team are quite difficult. Okay, so there's 665,280 different ways you could line up squad of 12 players with 6 players in the team and 6 different positions. Now, this is a different question. How many different teams are available? Now, you might think, well, that's the same question. Well, now, in the first question, we could have had the same 6 players, but in different positions. Okay, so this time it doesn't matter about positions, it's just about how many different teams are available. So it's 6 different, so this means 6 different players. Well, not necessarily 6 different players, but each team has a different combination of 6 different players. Okay. Now, for this, we need to determine how many of these 6, 5, 280, how many of those had the same players in, but just in different combinations. If we imagine 6 players, so if we just had 6 players and 6 players, how many different ways could they be ordered? Well, 6 different players. Did this earlier. So position A, B, C, D, F, and it doesn't. So position A 1. Position A, there's 6 different options. Position B, there's 5, and you'll find that that is 6 factorial, which was 720. So for 6 players, there could be 720 different starting lineups for 6. Okay. So to get the actual total number of different teams, we just need to do the total starting lineups divided by 720, because 720 was the number of different ways 6 could line up. We're interested in different players here, and we get an answer of 924 different possible teams. Okay, so slightly trickier at the end there. But you've got all the tools now to, I think, answer these questions. And just take some time, draw those boxes out and work out what could go where, and then multiply the options together. Okay. Right, so you've got some questions to do now. So questions from the textbook. It's on page 25, and I want you to do questions 2 to 14, evens only. Okay. You might want to do more than that if you want a little bit of practice, but it starts on page 25. I think it goes up to page 27. So evens only, and do more if you want to do a little bit more practice. But well done, guys. That's chapter 1 complete, and tune in next time for the start of chapter 2.